we're going over polynomials today. What we went over so far, and you're going to have a cumulative on all of these, but I'm going to give you a cumulative review questions as we go along before you write the cumulative. It'll be in 2 weeks. So your cumulative is going to be on what we started with, which was perms and cons, set theory, which is the circles, right, and diagrams. Then we did probability, which involved set theory and perms and cons and a little bit extra, which is like odds, and then rationals. That's what your cumulative is going to be on. Okay? So we're going to also have a unit test, oh my gosh, on polynomials.
Why?
Okay, so what is a polynomial? We've dealt with polynomials before. In grade 10, you guys did linear polynomials. So that was where it was just lines, right? Y equals mx plus b, and you did those in grade 9 and 8 as well. Then last year, it didn't matter what course you were in, -1 or -2, you did quadratics, which was degree 2, right? Polynomials. Today and this year, you're going to go over linear, you're going to go over quadratic, and we're going to add cubic, which is degree 3. Okay? Great thing about it is it's all calculator based. Okay? You don't have to like solve algebraically. Like if you're in 20-1 and you have to find the vertex, you have to complete the square. Out. All that stuff is out. So we get to do it with our calculators. Okay? So what is a polynomial? Well, I could do a constant, which is like y equals 6. That's a polynomial. We're going to talk about it in a second. It's called a constant function. It's just a horizontal line. So I would go to where y equals 6, and I'd have myself a horizontal line. It's a polynomial because I can write it as x to the power of 0. Because what's anything to the exponent 0? 1. Anything to the power of 0 is 1. So I can write x to the 0 beside it because x to the 0 is 1. 1 times 6 is 1, right? So it actually has an exponent of 0 when it doesn't have an x. It would be an x to the 0. We could also have a linear, like 3x plus 6. Well, this is an x to the 1, and this is technically an x to the 0. Do you agree? We could have y equals 6x squared plus 2x plus 4. Well, that's an x to the 2, this is an x to the 1, this is an x to the 0, technically, our constant. Or I could have a cubic. Y equals negative 3x cubed plus 6x squared minus 4x plus 7. 3, 2, 1, and 0 still, right? So a polynomial is an equation where all of your variables are whole numbers. Whole number exponents. So if my exponent is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, if all my exponents are whole numbers, it's a polynomial. Okay? That starts at 0 and goes onwards. What's not a polynomial? The opposite. Anything where it's not a whole number exponent. So an example could be y equals 3 plus root x. Going back to grade 10, your teacher taught you root x can be written as a fractional exponent. So if they gave you root x, that's actually x to the 1, right? If it doesn't have an exponent, the exponent is 1. And what's my index? What's my number above my radical if I don't have a number there? What's the number that goes here if I don't have a radical? If I don't have a number? It's a 2. It's the square root, right? It's a square root if it doesn't have a number. If it does have a number, it could be a cube root or a fourth root or a fifth root, right? Your teacher taught you that you can turn this radical into a fractional exponent by taking the index and dropping it under your exponent. So the square root of x can be written as x to the half. So they taught you that you can bring that index underneath. Yeah?
So you just divide it?
Mm-hmm. So we don't actually have to know how to do that. We just need to know that this is not a polynomial because it's the same as writing 3 plus x to the half. And is half a whole number? No, half's actually a rational number. So therefore, this is not a polynomial. Another example of a polynomial. Y equals 3 plus 2 to the x. Is my exponent a whole number? No, my exponent's actually a variable, isn't it? So that's not a polynomial either. Another one could be if I go y equals 2x squared plus 6x plus 3x to the negative 4. Oh my gosh. Is that negative 4 a whole number? Whole numbers from 0 positive, right? Is negative 4 a whole number? No, it's an integer, so it's not a polynomial. Another way I could write this, exact equation. It could be given to me like this. Is that x plane on the top? Nope. We were taught also in grade 10 that I can take this and I can bring this up here and raise it to a negative exponent. So these two equations are actually the exact same. So neither of them are polynomials. So if on a diploma they asked you which of the following is not a polynomial, you're going to look for an equation where its exponents are not whole numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How could that look? I could have a variable that's under a radical symbol because that would be pure fraction. I could have a variable in my exponent, or I could have a negative exponent, or my variable being on the denominator, which would make it be a negative exponent. All of those are not polynomials. Okay? Constant function. When you have like y equals 6. I had that up there. It's when it's y equals a number. So those are always horizontal lines. So this would be the equation y equals 6. Okay? We don't talk about constants a lot, and it doesn't really come up on diplomas, but I'm going to explain it just in case it does, because it is a polynomial. Now, what would its domain be? Remember, domain is x values, right? Are there any x values that don't exist on here? Nope, because here's x equals 0, here's x equals negative 1, negative 2, negative 3, negative 4, negative 5, 1, 2, 3, 4, 5, all the decimals in between, and on to infinity, correct? So if every x exists, what's your domain? X is now in the reals. You need to write it like this. You need to write squiggly bracket. You can't write a round bracket, you can't write a square bracket. You have to write a squiggly bracket. It's a forwards S, backwards S. If it kind of looks like a squiggly bracket, they'll accept it. If it's a square or a round, that's not the same thing. Now you might be like, why the heck would they care? Because in math terminology, if you go to the math terminology like dictionary, the math dictionary of words, a squiggly bracket means the set of. And we've discussed that, right? We've said it the whole time, the set of, and we use that in set theory, right? So we need the squiggly bracket. It means the set of x values, and we're going to use x because your equation would be in y equals whatever x is. So if your x variable happens to be a t, we'd have to use a t there. So it's whatever your x variable is. So it's x straight up and down line. What the heck does a straight up and down line mean in math? It means such that. So math symbols mean things, and that's why you need them. So we're going to go squiggly bracket, the set of x values such that. Why do we do this? Because we're saying, hey, the variable x is actually x in this question. Such that x is an element of the reals. So that means the element of that c with a little dash in it, reals. Now, if you put a full R like that, or your teacher taught you to do the R with the double line, doesn't matter, both will be accepted as reals. Okay, so you can just do a capital R, or you can do the R with the double lines if that's what your teacher taught you in class. Both work. They accept either. Okay? Now, my range for a constant. What y values exist on this graph? 6. That's the only one that exists, right? There's no y values below 6. There's no y values above 6. So I'm going to do range. My variable in this case is y. So I'm going to do range such that, the set of y's such that y equals 6. Literally all it is. Because the only values I have on here are 6. Right? How many x-intercepts do I have on here? How many times does this cross the x-axis? None. So for almost every constant except for 1, I have no x-intercepts. There is one constant function where I have an infinite number of x-intercepts. Do you know what that might be? What equation y equals what would give me an infinite number of x-intercepts? 0, because that's the actual x-axis, correct? So for every constant function except y equals 0, I have an infinite number of x-intercepts. What's another word for x-intercept? You're going to have to come get it with a mask on. Infinite number of x-intercepts, correct? What's another word for x-intercepts? There's 2 other words they use for x-intercepts all the time. Do you remember? It starts with an R. The base of a plant. Yeah. Roots. They can use that word. It means the same as x-intercepts. And the other one starts with a Z. It's actually a number. 0. So they could say x-intercepts, roots, or they could call them zeros. Those are interchangeable words for x-intercepts. So they could ask you for the number of roots. They could ask you for the number of zeros instead of asking you for the number of x-intercepts, and it's the same thing, and you need to know that. You can't call anyone over and be like, excuse me, what does roots mean? Excuse me, what does zeros mean? You need to know that that means x-intercepts. They're interchangeable. Okay? So only for y equals 0 are there infinite number of x-intercepts. Every other one, there's no x-intercepts because it can be completely above or completely below the x-axis, right? How many y-intercepts does this one have? 1. And the y-intercept is actually equal to the equation, right? So for constant functions, you have 1 y-intercept, and it is equal to the equation. So in this case, I had y equals 0 as my equation. My y-intercept is, or y equals 6 is the equation. Wow, that was hard. Y equals 6 is the equation. So y equals 6 is actually my y-intercept. 0, 6, technically. Okay? How many maxes or mins does this have? It's a really stupid question, and I hope you answer it properly. How many maxes and mins does this thing have? None. It's a straight horizontal line, right? There's no maxes or mins. Okay, we're going to flip over. Okay, this is where I'm going to need your undivided attention because this is a big learning day. Big learning day, and it will make your life so easy on this unit test if you pay attention. Big learning day. So we have a linear function. We have y equals ax plus b. Okay? I'm going to give you one. I'm going to give you y equals negative 2x plus 6. Y equals negative 2x plus 6. So we can type this into our calculator and we can go second graph and get a table of values to plot it. We agree? But I'm going to just use grade 10 math to plot it. I'm going to use slope and y-intercept. So my y-intercept is at 6, so I plot that first. So you're going to sketch these. Okay. So we're going to plot our y-intercept first, which is positive 6. 1, 2, 3, 4, 5, 6. Okay? Now this is where people mess up in grade 10, is they'll plot their y-intercept, and then they'll start at 0, 0 for their slope. You don't. You plot your y-intercept because your y-intercept is a starting point. Okay? Then we have a slope. Our slope is negative 2 over 1. So we rise before we run. And if you don't remember, think about getting out of bed in the morning. You rise and then you run. It would look really weird if you did that, but you rise and then you run. But what would look even more weird is if you ran before you rise. You'd just be running in bed. Creepishly weird. Your mom would walk in and be very scared. That would be what would happen. So think about getting out of bed. What do you have to do to get out of bed? You have to rise and then run. Slope is the same. So we have to rise. So it's negative 2, so we're actually going to rise down 2. And then we're going to run horizontally 1. Right? From your slope.
You get 1.
Because every number's over 1. If it's over Okay, so we start at the y, and we're going to go down to 1, 2, right 1, plot a dot. Then we're going to go down to right 1, plot a dot. Then we're going to go down to right 1, plot a dot. Down to right 1, plot a dot. Down to right 1, plot a dot. And we could keep going, right? Now, what if we wanted to go in the opposite direction? We just do the complete opposite. So we could start at 6, and instead of going down to right 1, we could do the complete opposite. We could go up to left 1, and it will still land on it. Okay? So you can start at your y-intercept and go down to right 1, down to right 1, down to right 1, down to right 1, or go back to your y-intercept and do the complete opposite, up to left 1, and we get this lovely line. I actually drew that kind of straight.
That's so straight.
I just set myself like some serious goals here because I can never draw these straight. So don't like think that that's how this is going to carry on. So on a test, if you had to draw these, please use something straight, so like a ruler, or if you don't have a ruler, everyone who usually has a calculator on the side of your calculator, you can use that as a side too. Okay. So we have that, correct? Okay. Now, please pay attention. My leading coefficient is the coefficient that leads the equation. So we're going to write this up here as a little definition for ourselves. The leading coefficient is the number in front of the largest exponent. Because coefficient means in front, leading means it has to lead the equation. So it's the number in front of the largest exponent. Sometimes you just ask the leading coefficient. So what number leads this equation?
6.
It's a number in front of the largest exponent.
-2.
-2. Because this is x to the 1, the 6 is x to the 0, so it's going to be the -2. Okay, guys? Stop. So my leading coefficient is -2. Now this is what you need to note. The sign of your leading coefficient tells you how you end on the right. Okay? So the sign of your leading coefficient tells you how you end on the right. We're going to write that as well. The sign of the leading coefficient tells you how you end on the right. So, what's the sign of my leading coefficient? Is it positive or negative? It's negative. So I go to my right side and I know it's going to end down. So I know this one's going to be down on right. Now, some people may say, how do I know how it's going to end on the left then? Well, I know how it's going to end on the left because it's going to be in the opposite direction, because linear is in opposite directions, correct? Linear is actually a degree 1. So it ends in opposite directions, so it's going to end up. I know. You need to stop. Because you're distracted. Me. Nope. Okay. So it's degree 1. All right. So it's down on the right, and then we know it's up on the left because odd degrees are in opposite directions. Okay? So the coefficient, and this has to be drilled into your head, you need to remember this. The sign of the leading coefficient tells you how it ends on the right. The degree, it tells you how it ends on the left. So if it's a degree 1, we know it's opposite directions, because we were taught that in grade 10, right? Opposite directions for degree 1. Okay, what's my y-intercept on this one? 6. So my y-intercept is at 6. This is another thing to note. So these are the two things we're going to take away that we get taught this year. The leading coefficient sign tells you how it ends on the right. So if it's negative, it ends down. Okay? The other thing we're going to learn about, and we're going to write this, our last thing we're going to write up here, is our constant. And what the heck is the constant? The constant is the number without a variable. So our constant is the number without a variable. It is equal to our y-intercept. But you guys, this only works if your equation doesn't have brackets in it. So our equation can't have brackets. If our equation doesn't have brackets, if it's just plain old like x plus something or x minus something, then the number without a variable is our y-intercept. Okay? We know it's mx plus b, and we know b is our y-intercept because we were taught that in grade 10. But it's also going to work for degree 2, and it's also going to work for degree 3 functions. So this is an odd degree, this is a degree 1, because it has an exponent of 1. So we know it's a degree 1 function. Okay? It's down on the right, we have a y-intercept of 0, 6. How many x-intercepts are we going to have for a linear function? 1. And we always have 1. We can't have more, we can't have less, because it's a straight arm, and it goes up and down, so it's going to cross somewhere, right? So the maximum number of x-intercepts and the minimum number of x-intercepts of a linear is 1. Your maximum number of x-intercepts is always equal to the degree as well. So we know that our maximum number of x-intercepts, and I'll bring this back up again. I'm going to put it here just so we don't forget. Max number of x-intercepts is equal to the degree. Our minimum in this case has to be 1 because arms are in opposite directions, right? So it's going to have to cross through somewhere. Someone has their hand up? Yeah.
Do you want us to write like the x-intercept?
Nope, just the number of them. We'll do that later. We're just going like, if we see this, we don't even have to sketch it, we can be able to answer this. So even if I just saw the equation, y equals negative 2x plus 6, I can tell you it ends down on the right, up on the left. I can tell you have a y-intercept of 6. And I can tell you that there's a maximum of 1 x-intercept and minimum of 1 x-intercept without even graphing it. Okay? What's my domain of this graph? Are there any, the easiest way, so this is, people struggle with domain and range since circa grade 10, struggle with domain and range. The way that I find to not struggle is if you say what does not exist for the x values on this graph. And if you can't find any that don't exist, it's XCR. So what x values don't exist on this graph? Are there any x values you can't find? So say I say 5. Yeah, there's a point for 5. What if I say 0? Yeah, there's a point for 0. What if I say negative 3? Yeah, I can find a point on this graph at negative 3, right? Are there any places I can't find a point on this graph for x? Nope, because it discos. Whenever your arms disco, your domain, unless it's a word problem, because word problems can be like time, and then you can't go negative time, right? Whenever you disco with arms, it's XER, YER. So when your graph is discoing, like if I threw a human in here, and those were his arms, and he's discoing, your domain and range are XER, YER. So it's going to be X such that X is an element of the reals, Y such that Y is an element of the reals. Now I'm going to give you an example to try. You're going to do exactly what I just did. So this one's going to be y equals 3 over 2 x minus 2. Sketch it. Give me the leading coefficient, y-intercept, number of x-intercepts, domain and range. So you're going to do all the exact same thing we just did. So you say down on right or up on right, exact same thing. Okay. So this one, I have a y-intercept at negative 2. And you could have went to your calculator and pulled values off and done it that way. But this one is a y-intercept of negative 2. And then I have a slope where I rise 3, run 2. So I'm going to go up 3 over 2. Up 3 over 2. Or I could go the complete opposite direction. And I could go down 3, left 2. Imagining that I didn't draw those lines, so stupid. My goodness. All right. That's more like my line. It's back. It's good. So what you're going to do, you could also type it in, right, and go second graph and pull points off and plot them. You could have done that. Now, my leading coefficient is 3/2. What's more important is that it's positive 3/2. My leading coefficient is the number that's in front of the largest exponent. My largest exponent is x to the 1. So my leading coefficient is positive 3/2. Now the 3/2 actually isn't even that important. It is helpful to draw if I'm going to sketch it. But what really matters here is the positive. Because the positive means that this graph is up on the right. And because it's a degree 1 function, I know it's down on the left.
How do you know that?
My leading coefficient tells me it's up on the right. And because it's a degree 1 function, I know it discos. So my arrow has to be down.
So what tells you that it's going to the upright?
The positive sign on the leading coefficient.
I guess it was negative, you'd be going down.
Yep.
On the right.
Yep.
How do you know if it's going left?
It's negative.
What do you mean it's going left?
Like, how do
It's
you-
always the right.
It's always the right.
Yeah.
Okay, that makes sense.
Yeah. So your sign of your coefficient tells you if you end down or up on the right. And the fact that it's a degree 1 means it ends opposite on the left. Okay, so the degree tells you how it ends on the left, but the sign has to tell you how it ends on the right first. Does that make sense? My y-intercept is my constant, so it's at 0 and -2. Now I can look at my graph and be like, yeah, it's at 0 and -2. It's a linear coefficient. But the constant is your y-intercept. So as long as your equation doesn't have brackets, that's your y-intercept every single time. As long as your equation doesn't have brackets, your constant is your y-intercept. Which for degree 1 isn't a big deal because you know it's y equals mx plus b, so you know it's your y-intercept. But it's going to be the same rule for degree 2 for quadratics and the same rule for cubics. Your constant will be your y-intercept. The number of x-intercepts is 1. And the reason why that is it's degree 1. So at maximum I can have 1. And because it's an odd function, I'm discoing, so I'm going to have to cross through at some point, so at minimum I can have 1. So the only number of options of x-intercepts I can have is 1. Yeah?
So if that was x, like 3 over 2x squared, there would be 2 x-intercepts?
There could be 2, 1, 0. We're going to talk about that.
The max?
Yes.
Okay.
So the maximum number of x-intercepts is equal to the degree. Yeah. So if it was degree 2, it would have maximum 2, but it doesn't have to. But a degree 1 has to have 1 because it maxes out at 1, and it has to have a minimum of 1 because arrows are in opposite directions. My domain and range, it's a little guy who's discoing again. Here's his arms, and then there's his legs down there. So it's going to be XER, YER, unless it's a word problem. Now I know it seems a little weird that I'm moving to cubic next, but cubic is also an odd degree function because it's degree 3. So we're going to do the odd degree functions together because their arms disco. So cubic function is a degree 3 function. This is the only one you haven't done so far. This is a degree 3 function. It's a cubic function. Cubic functions can look like this. They can have a max and a min. They can be a side like this. Or they can have a min and a max, like this. So they're going to have a max-min combo. Or they can just have a point of inflection, which is like this. They just curve. And then here, where they curve down, and then here, are neither maxes or mins. It's called a point of inflection. So they're either going to give you a max and a min, or they're going to give you a point of inflection. But we still follow the same rules of positive leading coefficients and negative leading coefficients. So I'm going to give you an equation. I'm going to one that works, not made out of my head because this may not work. So we're going to try y equals 2x cubed minus 15x squared plus 33x minus 20. We're going to type that into our calculators, and I am too. Okay, so we're going to type in 2x cubed. Now, how you can get the cubed quickly in every other exponent if you don't have a squared is you can go x, the little hat symbol. So this little roof symbol, it's right here. Really? Oh my gosh. Never done this before. I don't know why it's freezing. Okay, so we're going to go to, oops. I got some memory on. 2x cubed. Now yours might pop up like mine did, or you might just have that little roof symbol 3. It's totally fine. Both would mean the same thing. And then minus 15x squared. Now you have to put them in the way you say them. It's minus 15x squared, not negative 15x squared, correct? So you can't go negative 15x squared because that would be a multiplication, not a subtraction. So I'm going to go negative, or subtract 15x squared. You can use the squared symbol, or you can use the hat too. It's the same thing, little root 2. Plus 33x minus 20. Everyone following along with their calculators? So you're typing it into your calculator, and then my hint to you would be to go zoom 6. Zoom is your top middle button, 6. And that at least sets your window to the negative 10, 10, negative 10, 10 window. So if you had a weird window going on, at least it will get you back to there. So I'm going to go zoom 6. Okay? All right. Now we can go, please pay attention. We can go second graph and get a table of values. That can help. But we first need to get our maxes and mins, because if our maxes and mins are not perfect whole numbers and such, then we're going to have to actually use our calculator to find them, not just a table of values. So I find the max and mins myself, which you were taught last year, but we're going to go through and remember how to do it. So remember, if it makes a hill or a mountain, it's a maximum, because if you stood on there, you couldn't go any higher. If it makes a valley, you'd be standing on the bottom, it's a minimum, right? So on the very left here, this is a maximum. So I'm going to find that first. So how do I calculate anything? I'm going to go second trace, and the reason why is the little blue word up here above trace is calc. So whenever I go second trace, I'm calculating something. So you're going to all do that. Second trace. Now we're going to pick which one? 4, because I want to find a maximum, right? Now I need to be on the left round of it. Now this is what, okay, I have to teach you something because I did not know this, and then I didn't know where the heck my little blinker was, and then I just pressed randomly until hopefully it came up on the screen. But down here, it tells you where your little blinker is. My little blinker right currently now is at 0 and negative 20. So it's down here somewhere on the left, right? And I need to get on the left of that maximum. So I'm going to arrow to the right because it'll start coming back up. So now it's at 0.45 and negative 7. See, there it is. Now it's at 0.6 and negative 5. So I need to be on the left side of that minimum. So if I drew a line down the middle of the minimum, or the maximum, sorry, if I drew a line down the maximum, I don't know why I'm having such trouble talking today. I need to be on the left side of it. And am I on the left side of it? Yep. Could you be down here and be on the left? Yep. Here, left, yep. You just need to be on the left somewhere. And then you hit enter. Now I need to be on the direct right of it. So I'm just going to, there, I'm on the right of it. That's good enough. I could have literally just been on the left here, hit enter, then on the right here, hit enter. Like I don't need to be crazy far over. And then I hit enter when it says guess again. So left bound, I have to be on the left, hit enter. Right bound, I have to be on the right, hit enter. And when it says guess, I just hit enter again. So where is my maximum at? 1.6 and 2.6. So I'm going to go back to my graph. And I know I have a maximum at 1.6, comma 2.6. Right? Now what else do I need to find? The minimum. How am I going to do that? Well, I need to calculate something. So I'm going to go second, trace, which is calc, and this time I'm going to pick my minimum. And now I need to be on the left and right of my minimum. So there I'm on the left, I hit enter. Then I need to be on the right of it, and I hit enter. And then it says guess, so I just hit enter. And it's at 3.4 and negative 2.6, right? 3.4 and negative 2.6. Okay? I only need to use my calculator to get my max and my mins because the rest I can get from my brain, from the fact that I have an equation. Okay? So we're going to go back to the equation I wrote. What's my leading coefficient of this equation? 2. It's the number that is in front of the largest exponent. So I'm actually going to say plus 2 for my own welfare. Why am I going to say plus 2? Because it gives me the direction. On the what arm? The right. It's always the right arm. So I know from this positive 2 that my right arm is what? My right arm is positive. It's up. And because this is an odd degree function, my left arm will be down. Because it's degree 3. Because it's degree 3, I know it has to disco. In order to disco, it needs to be opposite directions. So degree 1 and degree 3 is disco. Arms in opposite directions. This one just does like a little wonky disco in it. Yeah. It's the negative 3? Oh, degree 3?
Yeah.
Because it's an x cubed function. Mm-hmm. What's my y-intercept at? Negative 20. Because my constant is always my y-intercept. So it's at 0 and negative 20 because I have a constant equal to negative 20. How many x-intercepts does this one have? 3. Now this is the catch. This one has 3, but degree 3 functions, if I have the number of possible x-intercepts, how many x-intercepts could it possibly have? Well, we know it would max out at 3 because it's a degree 3, right? Maximum number of x-intercepts is equal to the degree. Are the arms in opposite directions? Yeah. So it has to cross through at some point, correct? So what's my minimum number of x-intercepts for a degree 3? 1. It's going to have to cross through somewhere, right? The graph can't be completely above the x-axis or completely below because the arms are in opposite directions. So at some point it's going to have to cross. But it can also have 2. It can also have in between. And I'll show you what I mean. So degree 3 can look like this. It could have 3 x-intercepts, correct? Or it could have 2 where it goes through, comes down, hits the x-axis, and bounces straight back up. That would be 2. Or it can have 3. I did 3 already, sorry. Or it can have 1. Where that bounce is completely above or completely below. So it could go like this. And that's only 1. Right? My domain and range, it's discoing. It's doing a weird disco, but it's discoing. You still have the human, say he's in here. Then here's his legs. He's discoing, he's just doing some weird like blah, but he's still discoing, correct? In the end, his arms are up and down. So if they disco, my domain, and it's not a word problem, my domain is XER, YER for range. Now we're going to try and sketch it. Now this is what I'm going to tell you. I'm going to write this. I'm going to write YSCL, which means Y scale. I'm going to make my Y scale be 2. Why? Because I want it to cross through negative 20, and I don't want to draw 20 little ticks. So I'm going to say Y scale 2, so that means every tick is worth 2. Okay? Just because I make my Y scale 2, do I have to make my X scale be 2?
No.
Nope. So I'm going to say X scale 1. And when you change it, though, you have to remember you changed it. So you have to keep your brain thinking and not do it wrong. So I know I have a y-intercept at 0 and negative 20, so I'm going to do that one first. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I also want to plot my mins and my maxes on here, right? So I have a maximum at 1.6 and 2.6. Watch yourself because your y's are worth 2, right? My x's aren't. So I'm going to go to 1.6 halfway through and then 2.6, which is a little bit bigger than the first tick. That's going to be my maximum. My minimum's at 3.4 and negative 2.6. So 1, 2, 3.4, negative 2.6, so a little bit less than the tick. So you have to remember that you made your ticks worth 2 for the y's. So you're only going to go down 1 because each one's worth 2. Now what if I want points in between? Well, I just go second graph, and I can pull any points in between. 1, 0, 2, 2, 3, negative 2. Yep. Yep. So can you give me these points in between? So you go second graph, and you're going to give me these ones. 1, 0, 2, 2. Remember to draw them correctly. So 1, 0 is here. 2, 2 is actually here. Because remember, my y's are worth 2. And then what was the other one? 1, 0, 2, 2.
3, negative 2.
3, negative 2. And 4, 0. So it's going to go. Please make the minimums and maximums better than I did, first off. But please make them rounded. Don't go points. Don't make them pointy. Was the graph pointy here? Oh, I'm going to put it with marker. Graph wasn't pointy, right? So if yours is pointy, is that accurate? No. Yeah. Yeah. So I'm going to give you one to try, okay? I had them. They're X, R, Y, yeah. Because it's discoing. So we're going to have f of x. F of x is just the same as what? Y. It's just function notation. F of x equals negative 4x cubed plus 16x squared minus 16x plus 2. You're going to try it out. For this one, when I typed in the equation, I got a minimum at 0.7 and negative 2.7. Yeah, 0.6666, so it rounds to 0.7. And a maximum at 2.2. Yeah, but 0.6 is not actually. If you kept the decimal 0.6666, that's more accurate. But if you go,
I put 0.66 and then the line.
that would be okay. Yeah. But they might sometimes ask you for the x of the minimum to the nearest tenth, and then you have to say 0.7. Yep, you're right. So we go to sketch it. Bless you. So this x scale is 1. And this is a y scale of 1. This is what I'm going to do. So I have 0.7 and negative 2.7 is my minimum. I have 2 and 2 is my maximum. And I went off my graphing calculator. I got 0, 2. And I got 3 and negative 10. Now, I want to teach you something else in between here. Okay? Everyone paying attention? What I wanted to teach you is you can actually pull values in between. So say this isn't enough and you want it to be more accurate. Did I draw one of them wrong? 1 and negative 2. Something is wrong. Which one did I do? 2, 2. 3 and negative 10. 1 and negative 2. I think.
Why is it negative x? Why is that dot in the negative x?
Oh, it's 0.7. There we go. I'm like, something is wrong.
It's like negative 1 is at 30, y 38.
Yeah, it's 0.7 and negative 2.7. I did them backwards. I was like, this is not going to sketch something accurate. Okay. Shh. Guys, I'm recording, which means they can hear everything you're saying. All right. So, what I need you to do is say you want values in between. Okay? Everyone following along? So say I want a value at 1.5 for x. You can do this. You can go second. Now, 1.5 is not on my table, right? My table goes up by ones. So I can go second, trace, value. Go second, trace, value. So go second, trace, value. And then type in 1.5. It'll give you the corresponding y. What's it at? Pardon? 0.5. So I could also sketch 1.5 and 0.5.
On the test roll, we have to sketch it.
There's a good chance you might have to sketch it. Yeah.
For marks or just for helping?
For marks. Yeah.
On like the diploma, do we have to sketch our own graph or do they give us something?
So if they give you an actual thing on the diploma, they'd also give you a Cartesian plane, but you'd have to like label it y scale, x scale.
Okay. Yeah.
So just like a box with a.
Okay. If we like do a bad job of like actually drawing like the ticks and stuff on like your test, and we lose marks.
Yep. Because you're sketching a graph. You're not like. It'd be like if someone went like this.
Well, yeah, like if they're like a little bit like from here.
Or if it's this, I get this all the time. That doesn't look anything like your calculator. It's pointy. Like it has to look relatively similar.
Yeah.
And if I give you an actual graph, like right now I'm sketching off of a Cartesian plane where I'm doing the little ticks, right? So it's not going to be the most accurately drawn graph. But if you're given a graph where you actually have a Cartesian plane with like squares, you should have a pretty darn good accurate graph. Yeah.
Okay.
And because you have your calculator, you can literally get more values off it. I just showed you how. Second trace value, put in -1, put in 0.5, -0.5, you can get tons of points. So it's going to come down. Just bounce back up. Come back down. Now, I knew before even drawing this was down on the right. How did I know that? I knew before drawing this was down on the right. What gave that away? The negative leading coefficient. So I have a -4 as my leading coefficient. So that means it's down on the right. And because it's degree 3, it's an odd degree, I know it's up on the left. Correct?
So negative down, positive is up, and also right?
So it's on the right, yes.
No.
Yeah. Okay, so your leading coefficient tells you how it ends on the right. Sign of the leading coefficient end on the right. So you should write that down if you did not. Okay. All right. What's my y-intercept of this one? Without looking at the graphing calculator or without looking at my graph, what would it be? It's 2. Because my constant, the constant is the one without a variable. My constant equals 2. So my y-intercept is at 0 and 2. I don't even need to sketch it to know that. How many x-intercepts did this one have? 3. What if instead of saying the number of x-intercepts it has, what if I said the possible number of x-intercepts? Yeah, you'd say 1, 2, or 3. Difference between how many x-intercepts there are, possible number of x-intercepts. Very different question. Yeah?
So if it's a degree 2, then it would, you'd say like 1 or 2.
Be 0, 1, or 2. Because degree 2's arrows are up or down.
Why is it 0 in the degree 2?
Because your arrows are in opposite directions, so it's going to have to cross through at some point. But degree 2, which we haven't got to yet, but we did last year, your arrows are in the same direction, so the graph could be completely above or completely below. So you can have 0. But it's only with even degrees that can
That's the
happen.
same with degree 1, if you include, you wouldn't put a 0.
Right. Yeah.
You want us to always state the possibilities, or only if you ask for them?
Only if we ask for them. Yeah. Okay, what's the domain and range of these? Without even graphing it, I should know my domain and range. It's x now in the reals, y is now in the reals, because odd degree functions are x is now in the reals, y is now in the reals, because odd degree functions, disco, right? Degree 1, straight discos. Degree 3 has a little curvy disco going on, a little fancy disco. But still, domain is x, xer, and range is y, yer. So that's your degree 1 and degree 3. They're both odd. They follow the same information, right? I'm going to give you a little bit of questions. We're going to skip this part. We're coming back to that tomorrow. I want to go down to here. We're going to do a little bit of sketching. The next slide. So, yeah.
When we're doing the domain and range, we have to grade like d equals.
Domain equals, yeah. All right. Sketch the graph of the following equations given the particular values and state the domain and range. So this is why I told you we need to know that information about leading coefficients tell me how it ends on the right, degree tells me how it ends on the left, constant is my y-intercept. The reason why I need that is because they can give you stuff that doesn't even have numbers. Okay? So what are they saying here? They're saying y equals ax plus b, so it's linear. So we know it's either a straight line going up to the right or a straight line going down to the right. Correct? Because it's a line. It's going to be a straight line. We know that because it's degree 1. The other piece of information we know is a is greater than 0. If a is greater than 0, what does that tell me? It goes up to the right, and because it's degree 1, it's what on left? Down on left. Because degree 1's disco, right? So if it's a positive a, it's up on right, and it's down on left because it's a degree 1. They disco. They're opposite directions. Okay? The other piece of information it gave me is that b is greater than 0. What is my b? My b is my constant. What is my constant? Another word for the constant. It's my y-intercept. So if my b is greater than 0, it's telling me I have a positive y-intercept. That's the only information it gave me. So our sketches can look a little bit different than each other's, correct? But the things that do have to happen on our sketches is that I have to have a positive y-intercept. I have to be up on the right and down on the left. And it's a straight line because it's a degree 1. Right? That's what I do know. So I'm going to sketch my y-intercept first. So, boom. Done. Positive y-intercept. Could you pick anywhere above the x-axis? Yes, and you're still right. Now I know it needs to be up on right, down on left. So I'm going to go, boom, just drew one. Could you make it steeper? Could you go like this and still be correct? Yep. Could you make it less steep? Could I do this? Don't draw this, it's terrible. Could I draw that? No, because I'm not up on right. But I could make a little bit of an adjustment and draw it like that, and I'd be accurate, because it's still up on right, down on left. Barely, but it still is. Okay? You guys are going to try B, and then you're done. Then we're going through these and the degree 3 ones tomorrow, sketching them like this. Then we do degree 2. And we do the same thing, and we're going to answer a whole bunch of questions. Okay? So you're doing B. So for B, let's go through what we know. A, don't stop putting away stuff. A is less than 0 means A is what? Negative. So I know A is negative, which means it is down on right, and because it's degree 1, it's up on left, and it's a straight line because it's degree 1. B is greater than 0 means what? I have a positive y-intercept. So the first thing I'm going to sketch is my y-intercept. There we go. I want it there. So I'm going to put it. You can put it anywhere above the x-axis. And what I know is it needs to be down on right, up on left. Up on left, down on right. Done. Okay?